All right, well, time to crank up lesson 3 of chapter 9, area of trapezoid. Certainly going to need your calculator again today, so you might want to get it up, fired up there, and clear the memory and kind of clean it out. Let's go ahead and get circled up here on this lesson. We're going to go 1 through 8. Okay, and I'm on page 689. Okay, and then we're going to jump to number 16. Okay, and let's just do 16 through 23. Okay, and that will give us a good, uh, good feel for these trapezoids anyway. Okay, so let's get started. Today we're going to talk about finding the area of a trapezoid, and really a trapezoid is kind of a unique quadrilateral because, I talked to you a little bit earlier about, parallelograms, a square, it's a rectangle, it's a rhombus, and so on, but not all squares, and it gets confusing. But a trapezoid is pretty cut and dry. A trapezoid has one set of parallel sides. That's all. So this is parallel they'll never touch. This is parallel to this. And trapezoids could look like a lot of different things. If you look up here in this sample, this is also a trapezoid. It has these sides will never touch. These will, okay? And it's a quadrilateral. A trapezoid is a trapezoid. Nothing else is a trapezoid, okay? So you can't cross-reference it too much. The formula we need is very unique to the trapezoid, so it is. So it's called area equals 1/2 the height of the trapezoid. So when we talk about the height of the trapezoid, we still want to use that perpendicular height, that straight line. And then we put in parentheses of base 1 plus base 2. Okay, so we're going to add these two up. Now, you could call this base 1 and this base 2. It doesn't matter what order you're adding because it is the commutative property. Okay, and then down here they're going to give us the area and we're going to have to work backwards. So we got some unique problems here. All right, so let's get rocking and rolling. Here we go. So I'm going to take my 1/2 times the height, which is 8. Base 1 is 11 and base 2 is 6. I'm asking you to write that out, okay? And then at that point, you can plug it right into your calculator, and I'm going to substitute a half with 0.5 times 8, parenthesis, 11 plus 6, and hit enter, and there it is. And when I hit enter, it's 68 meters square, okay? So make sure you label it. It is area. It's in square units. Let's try that again. 1/2 times the height of 8. Base 1 is 7. Base 2 is 15.6. Yes, I do want you to write that out. It is important. So here we go. 0.5 times 8, parenthesis, 7 plus 15.6. And there it is. Or you could have just said, half of 8 is 4 and then multiply it by that. However it works for you is fine. And we're going to circle that answer. Okay. Okay. Good start here. Next one is the when they give us the area and we got to kind of work backwards. So, all right. I like to start with the formula because it tells me where to put the numbers. And you'll see what I mean. Okay. The area is 15, so I'm going to put that under my A. 1/2 is constant. Okay, I'm looking for the height, so 1/2 H, right? Base 1 is 4, base 2 is 6. Okay, and we simplify. 6 and 4 is 10. Half of 10 is 5. 5 what? 5H comes down. I just multiplied this by 10. I balance beam, divide by 5, H equals 3. 3 what? 3 feet. It's not area. We already have the area. Make sure you label that correctly, okay? So that's the easiest way to do it, the safest way. Okay, writing the formula and plugging it in. Let's go to the next page and get into some more problems here. So number one, here we go. And what I would say is maybe, at the top, write the formula down. Area is 1/2 the height of base 1 plus base 2. Okay, and here we go. So 1/2 times 12. Base 1 is 23, and base 2 is 5. And then I just plug it in, right? So, I'm going to do this a little bit different. I'm going to say 23 plus 5 is 28. And then I'm just going to multiply that by 6. You see what I did? I took half of 12 and got 6. And you get 168 yards square. Okay. If I wanted to paint it, that's how much paint I would need. Okay, let's go again. All right, so it's 1/2 times the height of 2. Base 1 is 1.1. Base 2 is 3.4. And here you go. So really, it's going to be 4.5 times 1, and I don't even need a calculator. It's 4 5/10 centimeters square, because this and this is 4 5/10. Half of that is 1. 1 times that is that. Let's go. 1/2 times the height. 8. Base 1 is 10.25. Base 2 is 17.75. And we're rolling. Okay. So I will use a calculator for this, right? 0.5 times 8 parenthesis 10.25 plus 17.75, and bam, it's 112. 112 what? Meters square. Yep. Okay, we're going to do one more. Okay, we're going to do one working backwards, and I'm going to take a look at number 5 here, okay? Okay, so I know I have the area, I have the base, I have the bases, and I have the area, okay? I'm looking for the height. So I'm going to write down the formula. Area is 1/2 the height, base 1 plus base 2, okay? I have the area. It's 400 equals. I'm looking for the height, so I'm going to call that h. You see, that's what we're going to solve this equation. Base 1 is 36, base 2 is 14. I'm going to simplify this side. The 400 is going to come down. 36, 46, right? 50. Half of 50 is 25. I just did a little bit of mental math. Added these two, got 50. Half of that is 25. And then I'm going to divide both sides by 25, and h is going to come down. And 400 divided by 25 is 16. Okay? 16 what? 16 millimeters. Okay? Right? It's not area. It is the height. Okay. So that's a good start. Okay, there's a couple challenging questions in here, but you should be fine with this. This is a pretty good lesson. All right, guys. I'll see you tomorrow.